A very warm welcome here from our showroom at the Einböck factory in Upper Austria. My name is Martin Wagner, and I'm happy that together with my colleague Thomas, we can give you a presentation of our farming practices and technology for mechanical weed control in the next minutes or maybe one hour. As I mentioned, my name is Martin Wagner. I'm responsible here at Einböck for the sales activities, and I'm with the company already more than 16 years, so I have a lot of experience in selling and distribution of the Einböck equipment all over the world.
My name is Berrer Thomas. I'm the responsible salesperson for the North American market, and I'm part of the Einböck team since 2017. On the weekend, I also run an organic farm on my own, and I have a lot of experience using our tools in the field.
We have recorded our presentation, so you will see in the future now the presentation with our farming practices and mechanical weed control details. Whenever there are questions during the presentation, please put them into the chat. We will answer them right away. If there are any questions later on, we are happy to answer them live via Zoom. I think we got introduced, so we can start with the presentation. On today's training, we'll have a look at mechanical weed control from the very basics. So we will have a very detailed look at the operation of tiled weeders and row crop cultivators. And Thomas will now give us an overview about what we'll see today in detail.
Our topics for today are why mechanical weed control. Another point will be the overview of weeding technology. There we're going to show you our types of weeders. We will also show you when will be the correct timing of using a tiled weeder and the correct setting of these machines. We will give you also an overview about our hoeing technology, about our hoeing toolbox. We will show you our new hoeing tools and all the additional equipment. And last but not least, we will show you the mechanical weed control in practice, that we will show you how to use our machines in cereals, maize, soya beans and sugar beets.
But before we start with today's topic, we want to give you a short overview about the Einböck company. We are a family-owned business founded in 1934. Currently it's run by the third and the fourth generation. We have our factory in Upper Austria, close to the German border, where we produce all our machines. So we have 100% in-house competence, starting with the development and design of the machines, over the production and the full sales and service and after sales process. We employ more than 225 employees. About 150 of them are working in the factory, in the production, and about 75 are in office, back office and sales. We have a very high production depth. This means we do all the metalworks in-house, so we really have a very good control over the quality. And we export to international markets about 90% of our annual production. Every year we have 15 to 20 apprentices, so young people are trained on the job, and most of them luckily continue then after they finish their education, continue to work with us in the company. The factory is about 75,000 square meters, which is a place of 11 football pitches So the area is quite impressive. And just last year we opened up our new second factory, which you can see on the picture aside, the new big building, which helps us to have more production capacity and to produce more efficiently. In respect of sales, we have two sales subsidiaries. One of them is in France and one is a joint venture which is in the United States. In all the other markets, we sell our equipment via dealers and importers. But coming back to today's topic, Thomas will now start with our today's topic, mechanical weed control.
Yeah, and there's the first question: why do we even need mechanical weed control? And especially for the organic farmers, it's the only possibility with the mechanical weed control to get rid of the weeds. Another point is the legislation on the reduction and prohibition of crop protection products. We also see a loss of active substances in the herbicides. Another point is the minimum distance to water courses. We also see a reduced acceptance of chemicals of the public. Furthermore, we see a resistance of certain weeds of herbicides. There are also new farming practices like fusion farming. That's a combination of mechanical and chemical weed control. And further on, there are other positive effects on the crop, which Martin will show you.
What are the objectives we want to achieve with the mechanical weed control? So, first of all, and the main reason is to control the weeds. So by reducing the amount of weeds in the field, I have a better basis for the crop to grow, so I can protect my crop. I break with this minimum of soil movement I'm doing with this very shallow operation, I break the capillary effect, so I support to keep the water in the ground and reduce evaporation. Especially on small grain crops, I stimulate tillering with this little movement of the soil I'm doing, and I also encourage the gas exchange between the soil and the air, so I have the effect of improved mineralization of nitrogen in the ground.
The mechanical weed control starts already before the season. We have to plan a crop rotation. We should plan also undersowing into our crop rotation and catch crops. And an effective tool to get rid of the weeds before seeding is already the stubble cultivation, because there we have already the possibility to remove a lot of weeds. The mechanical weed control must be part of the farming practice. It's not sufficient only to substitute a sprayer by a hoe or a tine weeder.
As Thomas mentioned, mechanical weed control is not only the operation of a tine weeder or an interrow crop cultivator. We need to adjust the full practice of farming on the farm. So even before I seed my crop, I can prepare the best circumstances, the best basis to control the weeds then while the crop is growing mechanically. And this starts basically right after the harvest of the previous crop. So with my tillage and stubble cultivation, I can not only stimulate weed seeds to germinate, so I can reduce the amount of lost crop in my field. I can incorporate organic matter, which will make it much more easy to run the tine weeder afterwards, and also an intercrop which may be in the field. The better the organic matter is incorporated in the ground and the better it's decomposed, the more easy it will be to run then my tine weeder or the interrow crop cultivator. So we can say the right stubble cultivation is the first measure in my mechanical weed control process. As I mentioned before, the more organic matter will be on top of the ground when I run my mechanical weeding tools, the more challenging will be my mechanical weed control operation.
Before seeding, we have to start with a correct seedbed preparation, and there we always suggest a flat and crumbled seedbed, and we always recommend to use duck foot sweeps on the seedbed preparation machine to make a nice cut over the surface, and the working depth and the adaptation of the soil should be perfect. And you see here on the left side of the drawing a nice seedbed preparation where the seed is placed at the perfect seeding depth, and over here you see here, for example, not 100% correct working depth of the seedbed preparation, and there it can happen that some seeds which are seeded into dry area don't start to grow. Regarding organic matter, there we have the possibility at the seedbed preparation to reduce the crop residues on the surface, and we should also try to distribute the residues over the whole field. With the seedbed preparation, we have the possibility to make a false seedbed so that we can eliminate the first weeds even before seeding our crops.
And the false seedbed means that we do a operation of, like we would prepare the seedbed for seeding some days before the actual seeding takes place. So we stimulate weed seeds to germinate, and right after the seeding process we do the same operation again. And here it's important, like you see on the drawing here, that you have an overlap with the duck foot sweeps. So you really cut the roots of all the germinated weeds. We have a clean field where we place our seeds, so the crop can germinate with a very limited competition of the weed seeds. We can also make our weed control more efficient by choosing the right timing. So for seeding, timing is a very crucial factor. So in spring we rather seed quite late in comparison to conventional farming, and in autumn, for autumn crops, we seed earlier than the conventional farmers, because then the crops have more time to get stronger established. As we work with mechanical tools on the surface, we choose a little deeper seeding depth than the conventional farmers. And as Thomas mentioned before, we need to do a very precise job, not only in respect of seedbed preparation, seeding depth. We also need to make sure we have very precise row spacings. So GPS is a very helpful tool for our mechanical weeding operation, so we can adjust our weeding machines very precisely to the conditions in the field. It's also very important that we have a very uniform germination of the crop, so that the crop plants grow more or less in the same speed and in the same size. So recompacting the soil after the seeding process, either with seeding rollers on the seeder or with a separate operation with a separate roller, also supports the success of our mechanical seeding later on.
Directly after seeding, we have the possibility for a blind weeding pass. This means I wait approximately 2 to 5 days after seeding, and then I use the first time already my tine weeder, and that is what you see here on the left picture, for example, using a tine weeder for blind weeding pass and potato hills. After the crop is emerged, we are able to use a tine weeder too, but then we have to wait a little bit. For example, in corn, we have to wait to the 2-3 leaf stadium so that the corn is well rooted and we don't hurt the corn too much. You see here on the right picture here our rotary hoe called ROTARYSTAR. That's a machine perfectly for breaking up the crust and can be also used for blind weeding, for example, or even when the crop is already emerged. In general, using a row crop cultivator, this can be only done after the emergence of the crop, so when the crop is visible. And here you see here on the picture our Jobster twin working in soya beans. And we always recommend at the last pass in corn, for example, to hill up a little bit to kill all the small weeds which are growing underneath the corn and to have a really nice and clean cornfield.
In respect of getting the best effect on the mechanical weed control, we have to take into consideration various conditions, so like growth stage of the weeds, weather conditions, soil conditions. The smaller the weeds are, the earlier I operate, the more efficient will be my weed control. I want to have dry, sunny and windy weather, so all the weeds I pour out from the ground, they lay on top, the sun and the wind will dry them out and they die. I have to be careful with humidity in the ground, because when the soil is not dry enough, I can support the building of crusts on top. And very important, I need to adjust the machine for each crop, for each field, because when it's not set up correctly, I can also do the opposite I want to achieve, and I could also damage or harm the crop itself. And depending on the soil structure, I also need to make sure I have the right settings.
So now I will give you an overview about the weeding technology. So in general, if we talk about the effects on the crop, so there we are loosening the soil, we are breaking up the heavy crust, we bring air into the soil, and especially at cereals, we support the tillering. Regarding the weeds, there we are spilling approx 50 to 70% of the weeds, and we damage and displant approx 30 to 50% of the weeds. And you see here nice on the right picture our little weeds which we pull out to the surface so that they dry out then during the day.
In tine weeding, the job itself is done by the weeder tine. So by adjusting the tine in respect of pressure, angle and working speed, I define the aggressivity of my weeding operation. Like you can see in the yellow field, tine pressure plus working speed plus tine angle is equal to the aggressivity of my operation. How I set my tine depends very much on the condition in the fields. If my weeds are stronger established, I would have to work with more pressure and maybe slower working speed. When the weeds are still small and lightly rooted, I can reduce the pressure but work faster. So you really have to adjust the setting of your tine depending on the conditions you have in each particular field. The tine position defines the amount of soil we are moving. So by moving the point to the front too much, I move little soil, and when I pull it, I move a lot of soil. And the second thing we have to take into consideration is when the crop grew up a little bigger. You can see on the right upper pictures, when I pull the tine, I will pull down the crop. So with having the point put forward to the 70 degrees angle, I will have the less aggressivity on the crop, but I still make sure that the tine will enter the ground very efficiently.
Here you see an overview about our tine weeders. The company Einböck is offering direct spring-loaded tine weeders and indirect spring-loaded tine weeders. A direct spring-loaded tine weeder is the AEROSTAR-CLASSIC, our all-rounder. Then we also offer the AEROSTAR-EXACT, the expert in tillage. An indirect spring-loaded tine weeder with a constant tine pressure. There we are offering our AEROSTAR-FUSION, the Absolute Pro. And a little unique tool for tine weeding is our rotation weeder, the AEROSTAR-ROTATION.
Talking about the AEROSTAR-CLASSIC is our all-round tine weeder, has proven its abilities and performance for many years. We have a direct spring-loaded tine. This means that the spring is part of the tine itself, so the aggressivity of the tine is defined by the thickness of the tine, and this means that the minimum aggressivity is always according to the tine diameter. So I have here a quite big minimum aggressivity, but for most of cereal crops, soybeans, corn, grassland, this machine has shown many years perfect results. Here you see some pictures in different crops like grains, corn, grassland, and as you can see in the right down corner, we produced the machine also in trailed versions up to 24 meters.
Now we come already to our precision time weeder, the AEROSTAR-EXACT. It's the expert for arable crops. Like on the AEROSTAR-CLASSIC, we have a line spacing of 2.5 centimeters and it's a direct spring-loaded time weeder. It's the perfect tool for cereals, soybeans, corn, beets, and other special crops. And through an additional wheel chassis at the rear of the machine, it's perfect for blind weeding because it's following the ground surface perfectly. Another big benefit of the AEROSTAR-EXACT is the simple and quick setting, for example, to adjust the aggressivity. And here you see an overview about our AEROSTAR-EXACT working in the field. For example, I told you that we have a rear chassis for a perfect ground following, which you see here, and that's perfectly for blind weeding, but can be also used for general weeding paths. For example, here in cereals, we also offer a seeding unit for this machine, so we can do undersowing paths in cereals. Also, a nice possibility of using the AEROSTAR-EXACT is to get rid of the goose grass in tall cereals. Here you see, for example, the machine working in barley.
The absolute pro, the most professional time weeder we're offering is the AEROSTAR-FUSION, which is the first of the machine we discuss now with an indirect spring-loaded tine. So this means I have separated the tine and the spring, so I can use springs which are thinner than the tine, so I can adjust the machine to work much more gently than on the direct spring-loaded tines. And what is more, with the split between tine and spring, I achieve that the tine pressure is the same on all the tines, independent from the position the tine is in. So this means, especially in hill crops, this is a very big advantage. On our Fusion we have the line spacing of 2.8 centimeters, and we can adjust the pressure from the dead weight of the tine to a 6 kilo per each tine. So we really have a very high variety of aggressivity we can adjust the machine to. Here you have some examples for using the AEROSTAR-FUSION, and as you can see, you can utilize it in every different crop because the setting is so unique and can be done so precisely.
As Martin told you, on the AEROSTAR-FUSION we are able to adjust the tine pressure from zero pressure up to 6 kilogram, and the big benefit of the AEROSTAR-FUSION is that we have always the same pressure. If we are working on the bottom of the hill, we have, for example, 3 kilograms of tine pressure, and if we work on top of the hill, we also reach the same tine pressure of 3 kilograms, for example. And here you see a nice video how to adjust manually the tine pressure on all the machines. This is gonna be done then hydraulically.
If we come to fields with organic matter or a big amount of residue in the field, a tine weeder could get in trouble and start collecting all this organic matter. This is why we have developed the AEROSTAR-ROTATION, where we put the springs or the tines on a disc which is rolling over the field. So this means it can handle much more trash than a standard tine weeder. We have a line spacing of 15 centimeters here. The star wheels are inclined on an angle this angle is set that the machine works the full surface, and this is also why on our machine the tine angle is not adjustable, because if you would change the angle of the inclination of the star wheels, you would have unworked stripes in the field where the tines did not work. Apart from fields with high residue or mulch till, this machine can also work more aggressive than a standard tined weeder because of the inclination of the star wheels, and especially with increased working speed you achieve a very high and big aggressivity of this machine. So it's also very suitable for fields with very heavy ground and with very thick crusts on top. Again, some examples of the machine in different crops: cereals, corn, soybeans, small stage, bigger stage. Very universal. Depending on the setting, the machine can be used according to your needs.
Nevertheless, sometimes we have some limits of using our machines, and one limit is always the size and the pressure of the weeds, especially for using a tine weeder. You can imagine if the weed is approx 10 centimeters tall, already well rooted, then we don't have any possibility anymore with a tine weeder to remove the weeds. There the only option is to use a row crop cultivator. Another important point or challenge is the organic matter on the surface, as you see here on the right bottom picture, because a standard tine weeder always collects, for example here on the picture, the corn stalks. Nevertheless, on our machines we always have the possibility to clean our machines directly from the tractor cab. So there we hydraulically move the tines backwards and then the machine cleans itself on the headland, for example. Another challenge is the humidity of the soil, because if it's too wet, we don't have the possibility to break up the crust and to remove the weeds. Another challenging point is a heavy crust. You can imagine if the crust is 2-3 centimeters thick, then the tine weeder is sometimes struggling to break up the crust and to kill the weeds.
Another tool we can use to control weeds mechanically or to break crusts is the rotary hoe. Our rotary hoe is called ROTARYSTAR, and the most important or the most efficient operation the machine does is breaking up crusts. So crust breaking is getting more and more important because the soil structure in many fields is getting a big challenge, and with the changing climate, with heavy rain in spring, the problem with crusts is getting bigger and bigger, and therefore a machine like this is doing a great effect in breaking these crusts and aerate the soil. The weed control is very much depending on the growth stage of the weeds. So the smaller the weeds, the more efficient the weed control of the ROTARYSTAR will be. So we can say the effect is divided something like 70 to 80% with breaking crusts and 20 to 30% in control of weeds.
Regarding the technical details about our ROTARYSTAR, there we have a line spacing of 9.4 centimeters, and on each star we have 16 exchangeable star points. We have a really large productivity because we can drive really fast, up to 25 kilometers per hour, and the working depth is typically 2 to 4 centimeters at the operation.
The ROTARYSTAR, as you can see, is a very unique machine and a very universal machine. It can work in many different crops, so basically in all field crops, and the operation is defined with the high working speed, so you get a very high productivity out of it. And it's working over this full surface, so it's an independent operation to the row.
So the ROTARYSTAR can be used on conventional farms. It's a perfect tool to break up the heavy crust. And here you see, for example, on the video, a ROTARYSTAR 1200 working on a conventional farm just to break up the crust. It's also interesting as an additional tool for organic farmers. It's also quite interesting for contractors and machine corporations.
From the row independent machines, we come to the machines working in between the rows, and here the mechanical weed control is getting more challenging because we really need to match the conditions in the field perfectly. As we have a crop which is growing in rows, we really need to fit our machine in between the rows and then find alternatives how to work in the row in between the plants. There are a lot of different possibilities which we will show you in the next slides. What you can see here is already a combination of mechanical and chemical tools to control the weeds, like inter-row crop cultivation in between the rows and a spraying operation on the row, for example. And we also can do a combination with the inter-row crop cultivation. We can place seeds in between the rows so we can seed an intercrop and establish it in corn or soybeans or whatever crop we are operating in.
An important question is at which kind of crop I want to use my row crop cultivator, because we are offering a wide range of equipment, for example different kind of sections, tines and knives, specially made for different kind of crops and row distances. Furthermore, we offer different kind of additional equipment for working in the row, for example finger weeders, rotation weeders and hillers.
But before we come to all these different possibilities we have, we need to make sure our machine or our inter-row crop cultivator fits our planter. The very basic and most important setup and message we have here is the number of seeded rows has to be the same like the numbers on my inter-row crop cultivator. It can be half of it, but it cannot be double. As you can see on the picture here, when I match the number of rows, I always have the half section working on the row where the passes meet, like here for example 12 row, or 6 row and 6 row. But if my planter is for example 18 rows and I work just 12 rows, I have my half section not there where it should be. And even if I steer during the planting my tractor with GPS, there is always a slight difference in the matching rows. So as with the high precision we are working on the inter-row crop cultivation, this little difference is already too much, so we cannot operate. Therefore it's really important that the number of rows on the planter and on the inter-row crop cultivator match.
Another important question is the row spacing, because for each individual row spacing we are offering different kind of sections. So for example at cereals we are typically working from 15 to 30 centimeters. There we are offering one time mounted on the parallelogram. If we talk about using a row crop cultivator in sugar beets and soya beans, there we usually have a row distance of 45 and 50 centimeters, and there we typically use 3 tines per parallelogram. In corn and sunflowers we typically have a row distance of 70 or 75 centimeters, and there we typically mount 5 tines per parallelogram. At pumpkin, there we usually have a row distance of 150 centimeters, and then we typically mount 2 corn sections together so that we reach the big row distance. And you see here at the drawing we have a really wide range of options and tools for working on each individual row distance.
When we talk about row spacings, we also need to make sure that our cultivator matches the tractor, and most important here is that it matches the track width of the tractor. As you can see here on the drawing, the track width of the tractor defines the number of rows which are in between the tractor wheels, like you have here on the lower picture. You see that there are 3 rows, crop rows, in between the tractor wheels. So this means I have an uneven number, usually on the standard cultivators with 8 or 12 rows. I have an uneven number of rows left and right from the tractor left. So this means my machine is asymmetric on a 225 centimeters track width. If I have a 150 track width on 75 centimeters row spacing, for example, I have 2 rows in between the tractor wheels. This means I have an even number of rows left and right from the tractor. So I have a symmetric machine. We can do asymmetric machines, but it's always better to have a symmetric cultivator, because otherwise you will always have a kind of side force which makes the machine not work 100% straight.
So if I want to start of using a row crop cultivator on my farm, I have to think about the productivity and the hectares per season, because you must imagine with a row crop cultivator we can do less compared to a usual conventional sprayer. In general, I should take into consideration if I want to have a front-mounted machine where I steer my machine on my own, or if I want to have a rear-mounted machine where we typically use then a camera steering system which guarantees us that we are working always on the 100% correct position. To choose the correct section for my farm, I have to identify if I'm gonna use it on an organic farm, a conventional, or even a fusion farming farm which combines chemicals and mechanical weed control, or if I even want to use it in minimum tillage or even in no tillage, where we have a lot of residues on the surface. The main goal should be to break up the crust and to kill all the weeds with our row crop cultivators.
The main setup of a hoeing machine is defined by the type of machine I'm using. Every machine consists of a mainframe. If this mainframe is steered with a steering system like you see here, the camera steering system, or with a simple upper link steering, or if it's a fixed connection to the tractor, depends on the size and on the wish of the customer. To the mainframe I mount my parallelogram, which is operating between every row, and to this parallelogram I mount the correct hoeing element to match the row spacing and to mount the correct hoeing tools depending on my field and crop condition. Behind the hoeing element I can add following tools, like you can see here, the finger weeder, we have a rotation weeder, or we can put various hilling elements.
At this video you see here a Jobster Prime. The machine is working here in sugar beets at the row distance of 50 centimeters and the track width is 200 centimeters. You see here the machine is equipped with hydraulic cylinders, so each section can be lifted up on the headland individually and the machine is steered by ISO section control. At the back end of the section you see we have a tine weeder mounted, which levels the ground after working through with the tines. And a little bit of special setup is the front tank in the front. There the customer is spraying herbicides directly on the sugar beets. So between the rows we remove the weeds with our sweeps, and on the row or in the row we remove the weeds with the herbicides. Here you see quite nice how the crop deflector discs protect the sugar beets from any soil flow or residues. And now we jump to our showroom and I show you our latest technology. Welcome back at our showroom. Now we are standing in front of our JobStar demo unit. First of all, I want to show you the differences of our tines. Let's start with the standard S tine, which is typically equipped with a 180 mm duckfoot sweep. The other option are our vibrotines. The benefit of the vibrotines is always that they work shallower to the ground compared to the S tines. And we have two options of vibrotines. One you see here, the standard vibrotine. And with a bigger sweep, we are offering the HD vibrotine. And there you see additional, we have mounted here even a reinforcement spring to guarantee that the sweep is going into the ground and working into the ground also at really heavy soil. Here you see our options regarding duckfoot sweeps, so a standard one, but we also offer for all tines, we are offering carbide tipped sweeps. Especially interesting for our customers who want to use a row crop cultivator in grain, we are offering ultra flat sweeps. The benefit of this system is we are moving less soil to the plant row, the soil is just moving over here, and with the shank we are moving no soil to the plant row. Another possibility to move less soil to the plant row, especially starting with row distance of 45-50 centimeters, we are offering angle knives. Now we are standing in front of our parallelogram. All our parallelograms are mounted on the frame with one bolt. So if I want to adjust the row distance, I just have to open this bolt and then I can slide the section to the necessary position. On each parallelogram we have always a reinforcement spring, and you see here 3 holes. So I can adjust the pressure of the spring by adjusting this part here. You see here in the front we have a feeler wheel, and the working depth is always adjusted by the spindle, and then the feeler wheel is moved down or upwards. A really nice feature on our parallelogram is also this little spring here, because this helps us to lift up, that we can use both hands to lift up the parallelogram. Then it locks automatically and it stays where it is. Let's have a look at our EIS section. This section is typically used for row distance from 30 up to 60 centimeters working width. The section is equipped with 3 tines, and the 2 outside ones can be adjusted according to the working width, and therefore I just have to open one bolt and then I can move the complete setup to the outside or to the inside. On this section we have also mounted our crop deflector plates. So now the plate is completely on the ground, so we protect the little soya beans, which are growing here for example, completely. And if the soya beans are getting bigger, I can lift up the crop deflector plates and lock it at lifted position. On the other side, I have, for example, crop deflector discs. They make sense if I have a lot of residues on the surface. They are working now in the ground, and if I don't want to use them, I just have to lift them up and then they are locked in lifted position. If I want to use them again, I just have to push a little lever and then it's going back to the ground. On the rear end side, you see our option for a drilled weeder tine to bring all the little weeds back on the surface so that they dry out on the surface, and then to get rid of all the weeds. The EMS section is typically used for a row distance from 60 centimeters up to 90 centimeters. This section is always equipped with 5 tines, and the 2 front tines can be always adjusted according to the working width. We have different kind of options to protect our little plants from the soil. One option is our ROTARYSTAR element. With this element we have the possibility that a little bit of soil is moving to the plant row, but through the spoons here we break up the crust and remove also some weeds in the plant row. Another option you see here on the right side, that's our crop deflector disc, especially interesting in fields with a lot of residues, and we completely protect our plants from any residues or soil. And if I don't want to use them anymore, for example in large corn, I just lift them up, it locks automatically and it stays where it is. On the next section here, you see for example the EMS section already mounted in the front. That's completely the same section as the rear version, just 180 degrees turned and mounted them on the same parallelogram. Here you see our crop deflector plates. They protect the corn or the plants over the whole working width of the section. Let's have a look at our complete new section, the Chopster Prime ERP version. This version is used from a row distance from 30 centimeters up to 60 centimeters, and we always mount 3 tines on the section. A nice feature is the locking system. We just need a big spanner. We open this little bolt and then we can adjust the front, the rear and also the front tine, and as soon as we lock the bolt again, both are fixed and tight again. A nice feature on the crop deflector plates, I can easily adjust the working height. And you can trust me, it stays where it should be. We can also offer crop deflector discs, and at the rear you see for example a drilled weeder tine unit. Let's have a look at our Chopster Prime, the EMP version. This version is typically used from a row distance of 60 centimeters up to 90 centimeters. We have mounted here 5 tines, and you see here our hydraulic cylinder. In combination with section control, we reach a lifting height up to 50 centimeters. We have here also our locking mechanism. If I open it, all the tines can be moved in or out. So I can adjust the whole section individually. And as soon as I lock the bolt again, everything is tight again. You see here in the front a little bit of special setup. So on the Chopster Prime can be also equipped with cutaway discs and angle knives. This really makes sense if you want to work really close to the plant row in small crops. Here we are standing in front of our finger weeders for the Chopster Prime. You see here they are directly mounted at the back of the Chopster Prime section. We follow the ground through a parallelogram, and I can adjust the pressure of the finger weeders through a spring, like you see here. If I don't want to use the finger weeders, I can lock them in lifted position. And the really nice feature, I can easily adjust how close I'm working to the plant row. I just open the mechanism here, and then I can move in or out the finger weeders, and as soon as I lock them again, they are tight and stay where they are. For example, at the last passing corn, if I want to use hilling elements instead of the finger weeders, it's easy to remove the finger weeders. I just have to remove one bolt, and then I can remove the finger weeders and add on then hilling elements, for example.
Now we are back in our presentation room, and we're gonna show you now our tools for working in the row. We are offering finger weeders, which are a universal tool to get rid of the weeds in the row, which you see here on the left side of the picture. These are 2 stars, and these stars remove all the weeds in the row. They are easy to adjust and can be used in nearly all kinds of crops. Another option of removing weeds in the row are our rotation weeders, which you see here on the right side. These are our rotation stars. They also remove all the weeds in the row, and they can be set up really aggressive, even more aggressive compared to the finger weeders.
Another tool to increase the precision and efficiency of interrow crop cultivation is the section control. This means I have a hydraulic cylinder on each of the parallelograms, so I can lift them at the headlands. As you can see on this example field here, a lot of fields are not square with only 90 degrees corners, so you have a lot of area which is unworked because of the setup of the row crop cultivator. In order to meet these ununiform areas, with the section control automatically steered by GPS or manually, lifts the sections not to damage the crops and the rows which run square on the headland as the knives are lifted up. We have on the JobStar Prime, we have a lifting height of up to 50 centimeters. On the standard machine, it's up to 38. It always depends on the type of soil and how deep the wheels run in the ground. Because of this, the lifting height may vary. This is an absolute precise operation, and I make sure that there is nearly no space for weeds to grow in my field with using the section control on the row crop cultivators.
To make the life of our tractor drivers a little bit easier, we are offering since 2015 an automatic camera controlled side shift frame. This means that we mount on the side of the row crop cultivator a camera which is always watching on the rows, and we have a side shift frame mounted between the tractor and the row crop cultivator, and this side shift frame is moving the row crop cultivator always to the perfect position so that we never kill any crops.
With this side shift frame, I have the possibility to work closer to the row, and this means my unworked area in between the rows is smaller. So the smaller the unworked area is, the smaller the space for weeds to grow is. And with this absolutely precise steering of our row guard system, as you can see, I really can reduce the unworked belt to the absolute minimum. If we just make a comparison without camera steering system, we would have about 13 centimeters, which is equal to 26% unworked area. With the row guard, the unworked area is up to 8 centimeters. So this means I have an unworked area of about 16%. If I have then the finger weeders attached, I nearly work the full surface, so roughly 95% of the field is worked, and I really can control the weeds very, very efficiently.
With the row guard, we also deliver a little monitor which is mounted in tractor cab, and with this little monitor which you see here on the left side, we can steer the whole system. We have 2 different kind of varieties of stabilization wheels: rubber wheels, which we typically suggest, and if the customer wants to use the side shift frame in really hilly conditions, we have metal wheels to have a 100% perfect stability. Standard, the machine comes with 1 camera, and optional, we're offering 2 cameras, one on the left and right picture, which you see here, which is really interesting, especially if we combine the system in combination with section control. On the left side, you see a little bit unique part here. That are our mechanical feelers. You can imagine if the crop is already canopied, then it's quite hard for the camera to see the rows. And with the mechanical feelers, we still have the option to use the side shift frame and to steer the row crop cultivator through the fields.
As a short summary, we have here summarized the top 10 points which are important in respect of hoeing. We touched most of these points already. Let me just go through them quickly again. We said before the numbers of the planter and of the inter-row crop cultivator have to match, so they have to be the same or maybe half on the cultivator. Adjustment of the machine should not be done at the headland, because there you have more soil compaction and the soil structure usually is not so good. So in respect of working depth, you might have different conditions there. You should bring the sweeps and the shovels as close as possible to the crop row. The most important area where we want to control the weeds is around the row or around the crop, but especially when the crop is bigger, take care not to go too close, not to damage the roots of the crop. The parallelograms should be adjusted so they decline slightly, so that in working position they go a little down. This makes sure you have enough downforce that the sweeps will enter the ground even in hot conditions, and the parallelogram has a lot of space to go up and down in uneven field conditions. In hoeing, there is one very important aspect to consider. Hoe as deep as necessary, so you will cut the full surface and cut all the weeds, but as shallow as possible in order to keep as much water as possible in the ground. In general, one can say the hoeing depth should be between 2 and 4 centimeters. The working speed during operation has to be adjusted to the soil conditions and to the crop conditions. Especially with the camera steering, you can go quite fast, but sometimes you have the problem that the sweeps move too much soil into the row and you might bury the crop. To cut the full surface is very important for weed control. This is why it's important to have duck foot sweeps which overlap, so you really cut also weeds which are already bigger and stronger rooted. You should constantly or on a regular basis get out of the tractor cabin and check the working result to see if you are not doing any damage to the crop. We are working in fields where a crop is growing, so if there is something wrong, we can also do damage. Therefore, a regular control is very important. Each field, each crop is different, each operation is different. Therefore, it's important to adjust the machine for every field depending on the conditions. And mechanical weed control involves a lot of experience, so therefore it's important that you remember how you adjusted the machines for particular conditions. Maybe it would make sense that you do a diary, so you can in next year remember what was the adjustment which gave you the best result the year before. And it's also good to share experience with colleagues who have similar problems, because everybody has a different opinion, different experience, and you will receive new ideas how you maybe can do better and achieve the best result. The next slides show a theoretical setup and way of using our machines in different crops. This can only be a proposal and can vary to different years and different fields, different conditions, but in general, out of our experience, this reflects the most use and combination of our machines in the different crops. If we look here at the grains, you can see it's always a combination of tine weeding, ROTARYSTAR and inter-row crop cultivation. It will be the same on the different crops, but here we can give you a little more details for each crop on the different crop sizes and crop stages. We will go over this very quickly, because anyway you will have to look in more details than later on, either on our handbook or on YouTube on our presentation. This is the overview for the grains, and here you have some pictures of the different machines in setup for small grains, tined weeders and interrow crop cultivators.
Here you see an overview about our weed control in corn. At corn we always have typically the possibility of using the tine weeder or a rotary hoe for a blind weeding pass, and then we usually wait to the 2 or 3 leaf stadium to use a tine weeder, a rotary hoe or a row crop cultivator again. On the left top picture you see here, for example, an AEROSTAR-FUSION working in small corn, 2 leaf stadio, and there we have to slow down the speed down to 3-4 kilometers per hour so that we remove the weeds, so that we don't hurt the corn too much. On the right top you see a row crop cultivator working in the 3-4 leaf stadium, and there they're already using finger weeders also. At the bottom pictures you see our rotary hoe and the AEROSTAR-ROTATION at the blind weeding pass approx 3-4 days after seeding.
In soybeans we also have the combination of tine weeding and interrow crop cultivation. When to use which tool you can see on the table here. What is very important on soybeans is especially when the crop comes out, so when the plant has this little hook on top, as you see here with 0.8 and 0.9. This is a very sensitive stage. You have to be very careful because with this hook you can very easily pour out the plant with the tined weeder. On soybeans we can also say that when the crop is out, it's very effective to bury it, so to control the weeds in the row just by burying them and killing them because they don't get any light. You can use for this the interrow crop cultivator with the finger weeders, and then several days after this operation, so 2 to 4 days later, you come with a tine weeder and you level out the field again and clean the rows, so the plant is getting the light back again. Especially for the harvesting it's very important to have a flat ground, so you have to be careful with the hilling on the last operation. On soybeans you see in the different stages the different machines, blind weeding with the AEROSTAR-FUSION, early interrow crop cultivation with the JOBSTAR Prime, and then with the bigger crop already with the camera steering system, and also the ROTARYSTAR can work in the soybeans in the earlier crop stages.
At sugar beets we have the possibility for a blind weeding pass, but then we have to take care about the seeding depth of the sugar beets, and we always have to adjust the tine weeder 100% correct so that we never pull out a little sugar beet seed. After the crop is emerged we can quite early use a row crop cultivator, but then we always suggest crop deflector discs to make a nice cut next to the crop, and the goal is not to move the soil where the crop is growing, because this would hurt the main crop too much. As soon as the crop is well rooted and 2 leaves are visible, we can use a tine weeder again, and then we can start use tine weeders and row crop cultivators in combination. Here you see on the left top picture our rotary hoe, the ROTARYSTAR, working in small sugar beets to break up the crust. Don't be afraid, the sugar beets are still alive. We just break up the crust and bring air into the soil. On the right top picture you see here a nice sugar beet field worked with our row crop cultivator plus finger weeders, and on the left bottom picture you see our AEROSTAR-FUSION doing a blind weeding pass in sugar beets, and on the right bottom picture you see our JOBSTAR Prime working with a camera steered side shift frame, the row guard, in small sugar beets.
Working in hills, for example potatoes, we also have the combination of the tined weeder. Here we use, instead of the sweep cultivator, we use reachers or rotative row crop cultivators like the ROLSTAR. Basically the principle works like moving the soil with either the tined weeder or with the rotative row crop cultivator, disturb the soil to control the weeds, and then use either the reacher or the rotative cultivator, the ROLSTAR, to push the soil up again on the hills to make sure the potatoes will not be exposed to the daylight and to maintain a good shape of the ridges. Here are some pictures with the Hillstar, the ridger to push up and maintain the hills. Then two pictures with the AEROSTAR-FUSION, where it's important to have the same pressure on the tines no matter if they work on top of the hill or down in the valley. And with the ROLSTAR, we can also either push up the soil on the hills again or first to push the soil down to control the width.
At canola, we always recommend to use a tine weeder 1-2 passes even before the canola is seeded to get rid of the first weeds. After seeding, we can use the tine weeder again for a blind weeding pass, but then we have to take care that we are not working too deep with our tines. And as soon as the crop is visible, then we can start using a row crop cultivator and a gently tine weeding pass. After the winter, typically we are only using a row crop cultivator again. Here you see some pictures of our row crop cultivator. Here, for example, at 6 row with finger weeders and working in canola. On the left bottom picture you see here crop deflector discs which protect the crop from any soil flow so that we never hurt the main crop. On the right bottom picture you see a little bit special machine, specially made for contractors. This machine is a double fold frame. At the moment it's working on 12 rows, but through the double fold system it's also possible to use this machine for an 18 row pass.
Sunflowers is very similar to corn. So with the wide row spacing, we usually do blind weeding or rotary hoeing. As soon as the crop comes out, we use again the combination of inter-row crop cultivation, tine weeding and or rotary hoeing, depending on whatever is needed in the particular field. Here you see different setups. For example, on the upper right hand corner you see a Chopster Verso working in sunflowers. With the cutting discs I can maintain quite a big amount of residue or organic matter in the field, and the discs, they cut a groove, so I make sure that I will not have residue brought into the row or I break up the soil and I damage the plant. This presentation was a short summary basically out of the information you can find in our handbooks. We have for the time being 3 handbooks, the organic and the fusion farming handbook, as well the handbook for grassland care. So you can get these handbooks, you can find either in the download section on our website, or if you want to get a printed version, please get in contact with us. We will send one to you with pleasure. Today's presentation was a short summary out of the organic farming handbook, so you can find much more details than what Thomas and I told you during this presentation in our organic farming handbook with a much more detailed information. So whoever is interested, please feel free to download or order an example of our organic farming handbook. We are very proud of it because it really contains a lot of information and a lot of details about our experience and about organic farming practices. We see more and more a trend in conventional farming to also make a combination with mechanical weed control, so to reduce the use of chemicals either of economic reasons or whatever reasons we discussed about at the beginning of our presentation. So our experience we summarized here in the Fusion Farming Handbook. This shall also be a guideline for conventional farmers who think about incorporating mechanical practices into their farming practice. Again, please feel free to order one with us or to download it from the download section. We will be happy to provide you our information and experience.
Now we want to say thank you to our audience, and we are looking forward to answer your questions at our Zoom meeting.